All right, welcome to Algebra 2. In this first video, we want you to focus on percents and charts. We want you to be able to take a fraction and write it as a percent, and also be able to convert between percents and decimals. Also, we want you to be able to interpret basic types of charts. Okay, percentages. A fraction expressed as a number out of 100. In the word percent, you have this prefix cent. Cent is meaning, like in the word century, 100. So you always know when you're doing percentages, you should be working with 100. So if they want you to convert a percent to decimal, like in these first examples here, two ways you can do it then. Percents are out of 100, so we can take 82 and divide it by 100, and that would result in the decimal 0.82. Okay, or the other way, since dividing by 100 moves the decimal place over 2 times, you can look where the decimal is, move it to the left once, twice, and it's going to end up to the left of the 8 like we see here, so you get 0.82. Doing that same trick with the next one, you could divide this by 100 or move it over twice. Now here, moving it over once puts the decimal to the left of the 2. Moving it a second time, though, would result in this empty space here. We would have to fill that place with a 0, and so as a decimal, this is going to come out to be 0.025. And again, you can divide by 100, get the same result. If you want to go decimal to percent, then we want to times by 100 or move the decimal the opposite way. So here we would move it 2 times to the right. So this decimal would be the same as 6.25%. Doing the same thing here, moving it over once puts it to the right of the 3. Moving it a second time results in this open space. Again, you guys fill open spaces with zeros. So 0.3 is the same as 30%. All right, if you want to go fraction to decimal, this one is probably most easily done with the calculator. You could also accomplish this by doing some long division, where you would see how many times 5 goes into 2. But calculators make that a lot quicker. So if we just take 2 divided by 5, fraction bar means to divide, you get the decimal 0.4. So 2/5 is the same as 0.4. You can do it very easily with the next one using calculator in a similar way. 9/4, 9 over 4 gives you 2.25. So this would be the same as 2.25. Okay, now if we want to take a fraction and go to a percentage, we want to use decimals as an in-between. So like we just did in those last 2 examples, if we want to take 4/7 and ultimately change that to a percentage, we want to use decimals as an in-between. So take 4 divided by 7, figure out what the decimal approximation is. So this is approximately, it's not exactly. Okay, so when we use these squiggly lines in math, that means approximately 0.571. It's not exact, it's about equal to that. Now if we take that and convert it to a percentage, we know about what percentage that is. So we could times by 100 or use our little trick of moving it over 2 times, and 4/7 is approximately equal to 57.1%. Okay. So some examples. These are some real life places where you might end up using percentages. Also, these are similar to things you may see on like the ACT test. So we want you to be able to accomplish these. The hotel manager needed to increase the cost of a room by 122% to keep up with expenses. A big key word in this problem is the word increase. Since we are increasing by a percentage, we need to know what we're starting at. And you always are starting at 100%. So if we take 100% and increase 22%, that means we are going to be at 122% of what we started with. The new rate of the room is $98. What was the original room rate? So we can solve a problem like this with a simple proportion that you've done before. So percentages, here we got 122, are always out of 100. Okay. Now we want to put that equal to the other information we have. Okay, and the other information is this $98. That's the new rate, the rate that went along with this 122%. So we want to put that $98 on top across from our 122. What we don't know is the original cost when it was 100%. So we want to put our missing variable on the bottom across from 100. If you recall, how you solve proportions like this is to cross multiply. So if we multiply 98 times 100, we get 9,800. If we multiply and cross multiply these other ones, we get 122x. And we can solve this with some simple math by now dividing. Cross multiply, divide, and we get our solution. So if you take that amount divided by 122, we will get that price. Okay, so jumping on calculator really quick here, you can see the original cost of the room is about $80, and if we round that, 33 cents. So the original cost was about $80.33. Okay, another way you could solve this problem, you don't have to use proportions to do it. You could do it by converting right away. So once we get this 122%, if you converted that to a decimal by dividing by 100 or moving that over 2 times, you'd get 1.22. So that percentage times whatever that original cost was should give us this new dollar amount of 98. Again, dividing, you can get the same answer. If you divide that out, that comes out to be the same answer of 80.33. So that's another way. If you like that way, by all means use it. I think most people like the proportion way, but you can do it whatever comes better to you or you understand better. All right, the next one, the cost of the car decreased by 27%. So similar to the last problem, we're changing our percentage, but here it's decrease. In the last one we added, decrease tells us we want to take our 100% and now subtract this new percentage, leaving us with 73%. So our value is going to be 73% of what it was. In the first, so going through the rest of the problem, in the first year, $1,275. What was the value of the car when it was bought? See if you can now set up a proportion to solve this out. All right. Hopefully you had a chance here. If not, pause it quick and try it. But what you should get here, you got 73%, always out of 100, is equivalent to what? This was after the change. Okay, because we want to find the original value, the value when it was at 100%. So we want to put this across from wherever 73 was. Cross multiply, divide, and you should get it. So if you cross multiply these, you're going to get this number. If you cross multiply the other two, you get 73x. Divide by 73, and you should have come up with an answer of $1,746.58. And again, you could do that with the decimal way. It should solve the same thing. Okay, a couple other problems along those lines. If you just get a simple problem where they're asking you a percentage out of numbers, we want you to be able to know what to do in these ones too. Some keywords in this. What percent of is telling us a total. Is a keyword for part of that total. So when we're sending up our little proportion here, we want to use that. So what percent, what out of 100 is going to be the same then? 600's our total. We want to put that on the bottom because the 100's our total with our percentages. 270's our part, like we're trying to find here. What out of 100 equals 270 out of 600? Cross multiply and divide, and just like our last problems, you can. So we got 600x would be equal to this, divide by 600, and you get an answer of 45. Now in this case, since they did ask what percent, we would want to answer that with a percentage, so 45%. The next one, if 40% of A is 30, then A is what percent of 50? Here, this is almost like two problems. We got this original problem trying to figure out A there, and then they ask us the second part, then A is what percent. So this is a two-part problem. Let's start with that first part. If 40% of A is 30, so we got 40%, percentages are always out of 100, okay? Of A, remember from before, of, that's our total, so we want to put A on the bottom, that's our total. Is our part, that means we want to put that on top. So cross multiply and divide this, and we can figure out what A is. So doing a little arithmetic there, we find out that A is going to end up being 75. Okay, now you got to be careful on like an ACT type test that you'll take here throughout your high school career. 75 is very likely going to be one of the answers. Don't pick that. You now got to do the second part and answer the second part of this problem. Then A is what percent of 50? So again, what percent, what out of 100, because we're trying to find what percent. A is, that's our part here. We know A is 75 of is indicating our total. Our total we want is on the bottom, 50. So we want to cross multiply and figure out what percent this gives us. If you kind of notice here, 75 is bigger than 50. So our percentage we get here should end up being bigger than 100 actually on this problem. So let's cross multiply. If we multiply 75 times 100, we'll get 7,500. Divide that by 50, and looks like the overall answer is 150. So we end up getting 150, meaning what percent? So the answer would be 150%. All right, why don't you pause the video here and try the next example, which is very similar to the problem we just did. Okay, let's kind of see what you got. Again, this is kind of a two-part problem here. So if 9 is X percent of 45, so what percent? Percents are out of 100. Of indicates our total here of 45 is 9 is our part. So if you cross multiply and divide there, you should have come up with 20%. And now we got to answer the second part of the problem. So what is X percent of 50? Okay, so we got another proportion here of 50. 50's our total. What is the percent? So we know our percent from before here is 20. 20 out of 100. We're trying to find out what that other little part is here. What is this going to be? So if you cross multiply and divide this, we end up with an answer of 10. So 10 would be 20% of 50. All right, one last one here, and then we'll shift to some other types of percentage problems. A number is increased by 25%. The resulting number is then decreased by 20%. The final number is what percent of the original number? Problems like this where we don't know the number and we're trying to find out that original number, it might just be good to pick something. Start with some number and just do these operations and see what your resulting number is of the percentage. So let's just pick something. Let's pick easy number like 100. Okay, so let's take that 100 and see what happens when we do these operations to it. So if we're starting with 100, let's see what happens when we increase it by 25%. So remember, increasing by 25%, that means we're taking our starting percentage of 100, adding on 25, resulting in 125%. What's 125% of 100? Well, set up a proportion. 125 out of 100% equals what new number? So we don't know this new number. Our starting number was 100. So if we cross multiply, divide that, we'd get 100x equals this, and then divide by 100. We actually should end up here with 125 as our new number. Okay, now it says the resulting number is decreased by 20%. Okay, decreasing by 20% means we're taking 100%, and subtracting 20%, we'd end up with 80%. So now we want to do a second proportion here to see what happens to our thing here. So we got 80 out of 100 equals, now our new starting number is 125. Okay, so we want to see where does 80% of that bring us to. So let's cross multiply here. We get 100 times x equals 80 times 125. So jumping on the calculator, let's figure that number out. We get 10,000, and then divide that by 100, which is pretty easy. Just knocking two of the zeros off, we would end up with 100. So what the final number is, what percent of the original number. We actually ended up with the same number that we started with. So if they're asking us what that percentage is, 100 out of 100, dividing those, or setting up a proportion, what percent? Well, if we cross multiply and divide that, we are going to get 100% because we ended up with the same number. So we get 100%. So increasing by 25% and then decreasing by 20% gives us the same value, no matter what your starting number is going to be. All right, percent change, an increase or decrease expressed as a percent. So when you're doing percent change, you want to find the difference in the amounts and put it over the original amount. Okay, difference means what's the change, and oftentimes if you are given something that's telling you to subtract, unless that they already gave you the change, then you would just put that change on top. But if they give you the new amount and the original amount, then you're going to want to subtract those to get the change. So you got to find the difference amount over the original amount. So looking at example 7, the number of students at Franklin High School increased, okay, from 840 to 910 over a 5-year period. What was the percent increase? Okay, so what percent out of 100 would result in this change? So here's where we want to do our original amount on bottom, the original amount from 840. So 840 is our original amount. On top, we need the difference. All right, to find our difference, we want to subtract the original and new amounts here to find the difference. So we want to take 910 and minus 840 to see what that gives us on top. Okay, so doing a quick little math here, that would give us a change of, looks like 70. So now cross multiply and divide, and you can get the answer. And I've already gone through and done that. You're going to end up with about 8.3%. Okay, why don't you pause the video now and try example 8, which is very similar. Okay, let's see what you got. The TV was originally 400. We want that on bottom. Okay, but is now 345. So we want on the top the change here. Originally 400 minus the 345. What was the change there for this decrease? Okay, so we want to put this equal to what out of 100 to find the percent, because they're asking us for a percent. So subtracting that tells us that the change was 55. Okay, cross multiply and divide, figure out the percentage, and looks like we get, or you should have gotten about 13.75%. Okay, that was the percent decrease. Okay, the last part of this unit is just looking at basic graphs and being able to interpret them. So here we got a bar graph talking about the number of birthdays of students by month. Key things to look at here, the title, because that's telling you what the graph's about. These labels on the two axes are important. So we got the months going across here from left to right. From bottom to top here, we got the number of students. So which month had the most birthdays? We probably want to look at which bar is the tallest here. We can see June. It looks like the most. If you follow that across, you can easily see that the number right there was 10. No other month got up to 10. So that means June had the most. With which month had the least? Doing a quick check, you can see August here. So we know August. Okay, for 3, what percent of the students have their birthday in May? Okay, so now this is a little bit more in depth here. We're not just looking for most or least. Now, to find that percentage, we'd want to know, one, how many were in May. Okay, so if we look at May here and follow it across, you can see 8. But we would also need to know how many total students. And they don't give us that on the chart directly. So that's something we would have to calculate out. So you do have to, on this one, looks like you'd have to go through and figure out the total each month, or the number each month, and then total that up. So here we got 3, 4, 2, 3, 10 that we already talked about with June, 6, 1, 7, 8, 4, and 7 on the last one. So adding all those up, that totals out to be 63 total students. So now we can figure this out. What percent, what out of 100? May, again, we talked about is 8, so 8 out of the total of 63. So do a little math there, and you get about 12.7%. All right, the last part on this, using the same bar graph, if 2,000 students are in Farmington High School, how many would have their birthday in the month of February if the same kind of thing held up, or these same kind of percentages or same kind of proportional birthdays held up? Okay, so in this case, we don't know how many of the 2,000. So we want to know how many out of the 2,000 students would result in the same sort of proportion or same amount as the birthday months in February. So looking at our graph here, February, we can see there's 4 out of what? Well, we found that total before, that's 63. So how many out of 2,000 would have the same proportionality as 4 out of 63? This isn't, we don't need to use percentages on here, but it's another proportion, so cross multiply. We want to multiply these two and divide by 63, so we get 63 times what equals 4 times 2,000 is going to be 8,000. Now divide by 63. Use the calculator. Quickly get the answer here. Looks like we get about 126.98 something, so very close to or about 127 students would have a birthday in February if the same proportionality held up. Okay, another type of chart you see very often are circle graphs or pie charts. In these, they're going to have some different categories. Here it's talking about some different types of food, and you may get questions asking stuff about this. So here it says, what percent of the voters polled chose burgers as their favorite food? Well, if you look here, you can see that there was 25 that liked burgers as their favorite. Okay, and we're trying to find a percentage, so we want to know what out of 100, but we're missing something here. We need that total. So just like before with the bar graph, to find a total, you'd want to add all these up. So looking at these numbers, you got 30, 25, 20, 13, and 7. Add all those up and find out the total is 95. So now we know the other number to put here. So cross multiply, divide, and it looks like you get about 26.3%. If this survey is indicative of the 20,000 people that live in Farmington, what is the best estimate of the number of people who like pizza? Okay, so how many people, X out of 20,000 people would like the same thing here? So now we want to do just like we did in this last one on finding that 25 out of 95. We want to know how many out of the 95 people in this poll liked pizza. Well, looking at the chart, you can see that 13 liked pizza. 13 out of 95 is the same as how many out of 20,000? Cross multiply and divide and you can get the answer. It comes out to be very close to 2,737 people. All right, last one. If you were to draw an accurate circle graph using a protractor, what would be the central angle for the sector measure for hot dog and fried chicken? Okay, so on this one, yeah, let's start with hot dog here. If we wanted to find the hot dog amount, you can look at the graph and again know that hot dog was 30 out of 95. Now, before when we did this, we would do what out of 100? That's for percentage. We're not doing percentage here, so we don't want to do out of 100. Here you got to go back to some of the stuff you learned in geometry. What do we know about angles in a circle from geometry? Well, hopefully from what you learned there, you know that the number of degrees around the circle is 360. Okay, just like some of those snowboard and skateboard riders that do all the trick moves, when you make a full revolution, they call it a 360, okay, because it's 360 degrees. So cross multiply and divide that, and it should tell us what the angle would be in the center of that circle for a hot dog. So cross multiplying and dividing that, you get 113.7 approximately, meaning that angle is about 113.7 degrees. The degrees symbol's that little circle up top after the number. So approximately that many degrees. Okay. Why don't you pause and see if you can do the same thing now for fried chicken. What would that central angle come out to be? All right, let's see what you got. What out of, how many degrees out of 360 would be the same as fried chicken was 20 out of the total of 95. So cross multiplying and dividing that, you should have came up with about 75.8, meaning about 75.8 degrees. Okay, all right, why don't you move on now, try some of the practice problems out.